Hello, this is Logan and Caitlin, and first off we're going to do arithmetic sequences.
Okay, for an arithmetic sequence, you do a common difference, which is given by D, and to find the common difference, you do A2 minus A1, or A3 minus A2, and then A4 minus A3, which equals D.
Okay, for example, to find a common difference and the next three numbers, what you would do is you would look at your numbers that were given, and we have 9/4, 2, 7/4, 3 halves, 5/4. Okay, so we would take A2 minus A1, and that would give us our common difference, which is -1/4. And if we keep subtracting 1/4 from each of these, the next number would be 1, or 4/4, and 3/4 and 1/2.
Now we're going to find the nth term, and to find the nth term, you use this equation, which is dn plus c. The d stands for the common difference that we found earlier, the n stands for a number, and c is a constant. And to find the constant, you take a1 minus the common difference.
Okay, for example, to find the nth term when given A8, which is the 8th number in the sequence, and A12, and A8 being 26 and A12 being 42, and find the 101st term. Okay, so what we would do is we would have A12 minus A8 over the number of terms in between, which would be 42 minus 26 over 4. And the common difference would be 4. Then we would take 4n plus c, and now we're going to find c. And to find c, you need a1. And to find a1, you have to take one of the numbers given, and you multiply the common difference times the numbers in between that given number, between a8 and a1. And that would be 7 times 4, which is the common difference. And if you did that and subtracted all that stuff, you would get -2. And a1 is -2. So then you would take a1, which is your first term, minus the common difference to give you -6. And that is c. So then we would take 4n minus c, and that would be our equation. And to find the 101st term, you would take 4, which is our common difference, times the number of terms, which is 101, minus 6, which would give you 398. And that's how you find the 101st term. Okay, this is arithmetic sums.
Okay, to find arithmetic sums, you're going to use this equation. Sn equals n over 2 times a1 plus an. N being the number of terms, a1 being the first term, and an being the last term.
For example, find the sum of the numbers from 1 to 50. Okay, so we have 50 terms, a1 equals 1, an equals 50. So we would do 50 divided by 2 times 50 plus 1. And that would be 25 times 51, which gives us 1,275. For our next example, we're going to find the sum of the first 150 terms of the sequence. And here's our sequence: 5, 16, 27, 38, 49, so on and so forth. And the first term is 5. So then what we're going to do is find the common difference. And you would take 16, which is a2, minus 5, and that would give you 11. Then we would take c, which is 5, which is our first term, a1, minus the common difference, and that would give you -6. Then you would plug that in to dn plus c, and that would be 11 times the number, which is 150, minus c, which is 6, and that would give you 1644 for the last term. Then you put it into the equation to find the sum, which would be 150 that is the total number of the sums divided by 2 times our first term plus our last term, which would be 75 times 1,649, which comes to be 123,675. Geometric sequences.
Okay, instead of a common difference like you do with arithmetic sequences, you have a common ratio, which is given by r, which instead of subtracting, you divide. A2 divided by A1, A3 divided by A2, A4 divided by A3, and so on.
Okay, to find out if a sequence is geometric, all of the ratios should be the same, and we have 5, 1, 0.2, and 0.04 for our first example. And you take two consecutive terms, and you take the one to the right and put it over the one to the left to find your ratio. Okay, and 1 over 5, of course, is 1/5. 0.2 over 1 is also 1/5, and 0.04 over 0.2 is 1/5. So our ratio is 1/5, and this is a geometric sequence.
Okay, now we're going to learn how to find the nth term. To find the nth term, you use a1r to the n minus 1.
Okay. Now, the problem is find the 8th term given that a1 equals 5 with a ratio of -1/10. So when we plug the numbers in, we have our a1 here, which is 5, and our ratio here, which is -1/10, and then to the power of 8 minus 1, which is 7. So when you put that into the calculator, you get -0.0000005, or more simply put, -5 times 10 to the -7th. Geometric sums.
To find the sum of a geometric sequence, you do a1 times 1 minus r to the n divided by 1 minus r.
Okay, for our first example, we are given that n equals 20 with a ratio of 3/2 and a1 being 3 times 3/2. Okay, so we would take that and we would plug it in, and our a1 would be 3 times 3/2, and 1 minus our ratio to the nth power, which is 1 minus 3/2 to the 20th power, over 1 minus our ratio, which is 3/2. And when you do the math, you get 29,918.34.
It's okay. With geometric sums, you also have infinite sums, where you use a different ratio, a1 divided by 1 minus r, which is our common ratio.
Okay, for example, you want to find the sum of 1 to infinity, given that 4 is a1 and your ratio is 0.6. So we would do 4 over 1 minus 0.6, which gives you 4 over 0.4, which is equal to 10.